All right, let's talk about functions. First, let's start with function notation. So before, when we had a two-dimensional system, we used x and y. And now we're going to use x and f of x. So instead of y, we have f of x, which is said f of x, which is short for function of x. So y is a function of x. So that's our notation. So you could write an ordered pair this way or this way. All right, in order to be a function, every input, x, must have exactly one output, y. Which of the following is a function? All right, when x is 3, y is 5. When x is 5, y is 7. When x is 3, y is 11. When x is 7, y is 12. So is this a function? If you said no, you would be correct, because sometimes when x is 3, y is 5, and other times when x is 3, y is 11. So we would call this a relation, not a function. Let's look at this one. When x is 3, y is 5. When x is 5, y is 7. When x is 7, y is 11. When x is 13, y is 20. Is this a function? If you said yes, you would be correct. All right, let's look at this example. When x is 2, y is 7. When x is 3, y is 5. When x is 4, y is 7. When x is 8, y is 11. Is this a function? And the answer is yes, this is a function. So two different x's can have the same y and still be a function, but the same x cannot have two different y's and have a function. What does that look like in a graph? Let's take a look at these three relations and ask ourselves which of these is a function. So for the first one, does every x have exactly one y? Well, let's look at this value of x. Sometimes this is the y value, and sometimes this is the y value. So if you guessed that this is not a function, you guessed correctly. What about this graph? Is this a function? Yes, every value of x has exactly one value of y. So one way you can think of this is if you pass a vertical line through it, if it only touches the function once, if it only touches the graph once, then it is a function. What about this graph? Is this a relation or a function? So if you can pass a vertical line through it and it touches it more than once, then it is not a function. A horizontal line can go through it more than once and still be a function. That's like this example. So the answer for this one is yes, this is a function of x. So we can call this the vertical line test. If a vertical line passes through the graph of a relation more than once, then it is not a function. Looking at this one, vertical line passes through it more than once, and that's why this is a relation and not a function. All right, this would be a good time to hit the pause button and answer the following question. Which of these graphs are functions? So they're all relations, but which ones are function? So we check the vertical line test. If a vertical line passes through it more than once, then it is a relation. So this one is not a function. This one, you try any vertical line, it only touches it once. So this is a function. You can see here already that this one is not a function. Try every possible vertical line here. This one is a function. This horizontal line is a function, but this vertical line is not a function. Let's write that down. So you can tell by looking at the graph if a relation is a function. How can you tell algebraically? Let's find out. Okay, first we'll review a couple of things. Recall that this symbol is called the principal square root. So if you use this symbol, it represents the positive answer. However, if you're solving the equation x squared equals 25, then x has two answers, positive 5 and negative 5. All right, let's use that to solve the following. So is x squared plus y squared equals 1 a function? And you may recall from chapter 1 that this is our unit circle whose center is at the origin and whose radius is equal to 1. So you already probably have a pretty good idea, but let's do it algebraically. So let's subtract x squared from both sides. And then when we solve for y, we have to recall that there are two answers. So we get y is plus or minus the principal square root of 1 minus x squared. So y equals plus the principal square root of 1 minus x squared is the graph of this half of the circle. And y equals negative the principal square root of 1 minus x squared is the graph of this half of the circle. So the answer is no, this is a relation. Let's do another one. So can you use algebra to answer this question? Is y squared equal to x a function? I would hit the pause button and try to answer that on your own. All right, so when you solve for y, you're going to get two answers. And because you have two answers, it's not a function. And if you were to look at the graph, y equals positive the square root of x is this part of the graph, and y equals negative square root of x is this part of the graph. And since it fails the vertical line test, It's a relation, not a function. Let's try another. All right, I would hit the pause button and answer this one on your own. Is 3x minus 4y equal to 12 a function? Well, if we solve for y, divide both sides by 4. We only get one answer. So we can write this in function notation. So the answer is yes. All right, y cubed equal to x. Is this a function? Why don't you hit pause and try that one on your own? All right, so if we solve for this one, we get y is the cube root of x. And you don't get plus or minus because when you cube a number, the sign does not change. So we only get one answer. So this is a function, and we can write it with function notation. And remember, you can also write that as x to the 1/3 power. Either one is fine. All right, what is the domain and range of the function whose graph is given below? And if I were you, I would hit the pause button, work this one out on your own. All right, so the values of x, the smallest value of x is 1. The largest value of x is 9, and these are closed circles, so those include those points. So you could say x is an element of the set from 1 to 9. What's the range of this function? Well, the lowest y value is 2. The highest y value is 9. So y is an element of the set from 2 to 9. Let's try another. All right, what is the domain and range of this function? So if I were you, I'd hit pause and do this one on your own. All right, the values of x. The smallest value of x is -3. And the largest value of x is 7. Now the range are the highest and lowest y values. So they don't have to be the endpoints. In this case, the smallest y value is -4. And the largest y value is +4. All right, what is the domain and range of this function? And because this one has arrows at the end, that means it goes off in that direction forever. All right. So because this function goes forever in both directions, the domain is all real numbers. So we can use that symbol. Or you could also write it as going from -infinity to +infinity. What's the range of this function? Well, the lowest value of y is 1. And it goes off forever in this direction. So the highest value is +infinity. All right, sometimes you need to find the domain of a function, and you just need to remember what restrictions there are on that type of function. For example, you can only take the square root of a positive number if you want a real answer. So we just have to make sure that x minus 4 is greater than or equal to 0. Add 4 to both sides. So the domain of this function is the set of numbers from 4 to infinity. Let's try another. All right, so can you find the domain of f of x equals the square root of 2x plus 5? I would hit pause and try that one on your own. All right, so all we need to do is make sure that 2x plus 5 is greater than or equal to 0. So x just needs to be greater than or equal to negative 5 over 2. So the domain is from negative 2.5 to infinity. Let's try another. All right, can you find the domain of f of x equals the square root of 4 minus 2x? So I would hit pause and try that one on your own. All right, just need to make sure that 4 minus 2x is greater than or equal to 0. Subtract 4 from both sides. Remember, when you multiply or divide both sides by negative, you change the sign of the inequality. So this set goes from negative infinity up to 2 and includes the 2. Let's try another. All right, can you find the domain of f of x is 1 divided by x minus 3? All right, try that one on your own. So remember, you cannot divide by 0. So x minus 3 cannot equal 0. That means x cannot equal 3. So you could write this as all real numbers, x not equal to 3. Let's try another. You can also just write it as x not equal to 3. It's a lot simpler. Let's try another. All right, what's the domain of 1 divided by x plus 5? So x plus 5 cannot equal 0. So x cannot equal negative 5. Let's try another. All right, can you find the domain of f of x is 1 over x minus 3 times x plus 2? So similar to the others, this cannot be equal to 0. So neither factor can be 0 using the 0 factor property. And you can probably just do that in your head. X cannot be equal to negative 2 or positive 3. Let's try another. All right, let's find the domain of this function. And you might be tempted to simplify right away, but you want to find the domain before you simplify. Let me write that down for you. So the domain of this function is x is not equal to 1. So what does that look like in the graph? Well, this part of the function is equal to 1, so it doesn't affect the way the graph looks. So the graph is going to look like y equals x plus 2, which is a linear function whose slope is 1 and goes through the point 0, 2. But what happens when it gets to x equals 1? So there'll be a hole in the graph. So generally we plot that with an open circle. And that break in the graph is called a discontinuity. All right, can you find the domain of this function? All right, so remember you have to find the domain before you simplify. So the denominator cannot be equal to 0. So the domain is x not equal to 2. So x equal to 2 is not in the graph of the function. This part of the function is equal to 1. So this function is going to look like y equals x plus 5. Only there'll be a hole in it at x equals 2. So it'll have a discontinuity at x equals 2. And there you have it.